Did it work? Off school Wi-Fi? Outside
What?
of school?
Yeah, it took forever, but we'll have to figure. Oh no, I didn't take it home. I'll have to tell you later. Okay, so everybody, what are perfect roots? Like perfect square roots, perfect cube roots. It means that they come out as a whole number. The answer comes out as a whole number. Now, it is not required, but it is useful if you can start memorizing some perfect roots. So just keep in mind, if 4 squared equals 16, that means when we square root 16, it's going to equal 4.
Correct.
So if you said to me, like, what is a square root? It's something squared equals that number, you know? So once again, if 2 cubed equals 8, then that means the cube root of 8 calculates to be 2. So we're focusing on radicals today. We saw some radicals last time. You'll see why sometimes fractional exponents are better and sometimes radicals are better. So let's just go through and start memorizing some of these. Here are some perfect square roots. So here's my square roots. We're not going to do a million, like, all different roots. We're going to just start with square roots. So let's memorize this. What is the square root of 1? 1. Let's all memorize that. The square root of 1 is just 1. The square root of 2 is a decimal. That's not a perfect square root. I'm just pointing out. It's not that it's a bad thing. It's just a decimal. Now, do I want the decimal? No. I want the pretty answer. The pretty answer is square root of 2. Do you guys understand? Yeah. That is mathematically a great answer. Square root of 2. Okay, square root of 4 is 2, right, everyone? We're memorizing. That is a perfect square root. Square root of 5 is a decimal. So we're not going to do that one. Square root of 6 is a decimal. Okay, so I'm going to skip square root of 7, 8. Is anyone mad about that? Square root of 7, square root of 8. Moving on. Square root of 9 is 3. Square root of 16 is the next one. So these are our perfect square roots. It's just kind of nice to have those memorized. Okay, now keep in mind right here, cube roots do not have eyes. So if I were to, and we'll get into that. So right here, I want to point out something. What's the cube root of 1? It's 1, and here's why. 1 cubed calculates to be 1, true? Which means the cube root of 1 is 1. Now let me point something else out. The cube root of negative 1 is not I. It's negative 1. And here's why. It's because negative 1 cubed is not I. Isn't negative 1 cubed negative 1 times negative 1 times negative 1? Which is negative 1. So everybody, odd radicals do not have eyes. Does everybody see?
Are you talking about imaginaries?
Yes. Do not have imaginaries.
Nobody knows what an imaginary is.
Well, we haven't even got there yet. Okay, cube root of 2. Cube root of 2 is it a perfect cube root? Is anything cubed 2? Not that we can do. Okay, so the cube root of 2 is a decimal. Cube root of 3 is it a perfect cube root? Anything cubed equal 3? No, it's a decimal. Cube root of 4. Nope. Decimal. Okay. Cube root of 5. Decimal. Cube root of 6.
2.
No. Cube root of 6. You're telling me 2 cubed is 6 if you say that. Okay, all right. No, that's good. I'm just saying, if you tell me that the cube root of 6 is 2, then you're saying 2 cubed is 6, which isn't wrong, right? All right, cube root of 7 is a decimal. Cube root of 8 is 2. What's the cube root of negative 8?
2.
Nope.
Negative 2.
Negative 2. Okay, awesome. All right.
Square root of negative 8 is 2.
The cube root of negative 8 is negative 2. Is that what you said? All right. All right, so I also wanted to actually, and maybe I'll do it up here so that it's on my video. I wanted to show you 2 ways to think of this. Everybody, let's write this down, what I'm writing in blue. Square root of 4.
Square root of negative 8. Hold up.
You guys are getting too worked up right now. Just keep watching. We're going to get to that stuff. Okay, square root of 4 is 2. True? You have that memorized. Now let me show you technically why it's 2. Another way to think about it. This is helpful for advanced thinkers. So do you guys know that when you have a square root and something squared, they're actually inverses and they cancel out? Did you guys know that already? I don't know what you learned in Sec 1. Square roots and squares cancel out. They're inverses, they undo. Just like addition undoes subtraction. Does addition undo subtraction? What undoes multiplication? Division, right, everyone? So square roots and squares cancel out. So let me show you what the square root of 4 is technically. This is the square root of 2 times 2. True? Is 4 2 times 2? Have I changed this? No, I changed the look of it. Now, here is the thing. We know that if it's 2 times 2, there's another way to write that. Isn't that the same thing as 2 squared? So what I have here is the square root of 2 squared. I haven't changed anything mathematically. I've changed the look of my problem. Do you guys see? Yes. So then from there, this is just a different way of calculating a square root. Now I can say my root and power cancel out, so the answer is 2. Now it's a lot easier to just memorize the square root of 4 is 2, but I wanted to show you another way because it comes up later. All right, write down the word in your notes, even roots. So I would write down what I wrote exactly up here. Even roots have positive answers or imaginary answers. It is not possible to take an even root. So even roots are square roots, fourth roots, sixth roots. You cannot take a even root and get out a negative answer. It's not possible. So let me explain. Roots, one more time. If we have the square root of 4, it comes out to be positive 2. Do you guys agree that's a positive answer? Okay. Now watch. If we do the square root of negative 4, it comes out to be 2i. 2i. We'll get into y in just a minute. But once again, I'm showing you the answer out. We're going to get into y in just a minute. Just trust me for a minute. So I'm showing you here 2i is an imaginary answer. So imaginary answers are what we're going to see, or positive answers. It is not possible to get a negative answer for an even root. Yes. You sure? Okay. Then let's go on to odd roots. Write this down. Odd roots have positive or negative answers. So odd roots do not ever have an imaginary piece to its answer. Let me say that again. Odd roots have positive answers and negative answers. They are not imaginary answers ever. So let me rephrase. Let's memorize it. Even roots are going to have positive answers or imaginary answers. Odd roots are going to have positive answers or negative answers. All right. So mathematically, we learn, you guys should know at this point in your math careers, that the square root of negative 1 calculates to be I. We're not getting into what I is right now.
I feel like this is people that invented math. This is kind of just a stretch.
Nope, imaginary numbers exist in the real world, actually. So,
Negative 1 times negative 1 is times negative I. Negative I to the...
okay, we're getting distracted and you guys are making my lesson suck, so stop. All right, so everybody, the square root of negative 1 calculates out to be I. So you need to understand that. So that when we see the square root of negative 1, we call it I instead. I is more simplified than leaving it as the square root of negative 1. So that's how we simplify it. Is square root of 4 more simplified or 2? 2. Is the square root of negative 1 more simplified or I? I is more simplified. Now, if that's the case, right here, everybody look, if the square root of negative 1 equals I, then we know also this mathematically is also true. We know I squared calculates to be negative 1. Now look, I'm going to show you mathematically why. Let's start back at the beginning. If we have the square root of negative 1 equals I, could I, if I wanted, do anything I want to both sides of the equation? As long as I do it to both sides. Yes? Yes, you can. We all know math. Math is math. If I want to do something to an equation, what do? We do it to both sides. Okay. So if I wanted, could I square both sides? Why not? Yeah?
Yes.
So I'm going to choose to square both sides. Watch. So now what happens on the left? The square root and square cancel out. True?
Yes.
So now we know mathematically negative 1 is equal to I squared. So when we see I squared, it's more simplified to write it instead as the number negative 1. They're the same thing. They're equal. So when I see I squared, you'd say, oh, that's negative 1. Negative 1's more simplified. And vice versa. When I see the square root of negative 1, we write it as I because I is more simplified than the square root of negative 1. Now that is not true for odd roots. Everybody look. What's the cube root of negative 1? Negative 1. It is not I. Odd radicals do not have I. Why? Because cube roots, think about why. Because cubes are negatives, true? Yeah. Something cubed is negative. Therefore, you can cube root a negative, and it's not I. It's just the number. It's just negative 1. All right, so once again, Let's just start simplifying radicals. Okay, let's write down these 2 examples. All right, so we're gonna do this like the most basic, like totally, like most, how do I say this nicely? No, how do I say this nicely? We're gonna do this the most
Comprehensible.
no, like you guys are making me more confused. We're gonna be doing this in a way that's like it's a memorization thing, not an understanding thing. And then I'm gonna instead encourage you to do it with more of understanding. So I'm gonna teach you a process to simplifying, and it's gonna be like, why are we doing that? And then we're gonna go over why. Yes.
I thought I was a function.
What do you want?
I mean, that just doesn't quite really, like, I mean, we're getting way into eyes right now, and that's not what we're doing in this lesson. So we'll get into more deeply into eyes later. So, I mean, you might be right, but we're not getting into that. We're just simplifying radicals. All right, so everybody, here we go. Let's simplify radicals. So if you're going to do this the most basic way, the easiest way they recommend doing it is breaking it down into its linear factors. That means factoring it clear down. Factoring, by definition, means pull this out to multiplication. It's most multiplied form. So everybody, let's start with the square root of 49x squared. What we recommend doing until we get really good at this is breaking it out into factors. Factors mean what multiply to be me. What multiplies to be 49, my friends?
7.
7 times 7. And then x squared is x times x. True?
True.
So now we have not changed the problem. We've just rewritten it in its most factored format. Now at this point, everyone, if at this point, we can think of this 2 different ways. I'm going to go way number 1 and way number 2. So everybody, way number 2 is actually understanding the math behind it. Way number 1 is memorizing a process. So everybody, we're going to see both ways. So way number 2 is as follows. How could we rewrite 7 times 7 if we want? 49, but then we're going backwards. Let's write it a different way. 7 squared. So write it like that. Now, it was a times sign in the beginning, so it's still a times sign. Math is math. It doesn't magically become addition. So now we're timesing that to x squared. Now, I'm going to say, instead of x times x, I'm actually going to go back to x squared. I'm going to write it as exponents. Now, why is this nice? Because what happens now?
Now the square root goes away.
Yep, the roots cancels out with the powers. Is that true? Does a square root undo a square?
That is true.
So what does that leave me with?
7x.
7 and x. So there's our answer, 7x.
What?
So you're square rooting in sections. Look, you literally square rooted 7. Listen, we're square rooting 7 squared. What's the square root of 7 squared? 7. We're then square rooting x squared. What's the square root of x squared? X. We are literally just square rooting in sections. Do you understand the math behind it? Yes?
Yes.
Okay, awesome. Now, a different way of doing this is kind of memorizing a process. So what you can do is go back to this. You guys are talking and you're making me suck at teaching because I cannot think. All right, you're going to pull out groups of however large the radical is. What's the radical number right there?
2.
A 2, a secret 2. So we pull out groups of 2. So right here, we're pulling out, you just pull out a 7, not 2 7s. We are taking the square root of 49. Does everybody see? What is the square root of 49? 7. That's why we only pull out 1 7 for the 2 7s. Do you guys see what I'm saying? Now right here, there's a group of 2, so we're pulling it out. We only pull out 1. So what would it be? X, 7x. That's just a different way of doing it. Pulling out groups of that size.
It's the same.
It's the same, but we're thinking differently about it. Have you guys in secondary math 1 simplified radicals before? Never? Not ever.
Surely you guys did.
I was just curious.
So like tree basically like split up.
Yeah, but I don't do the tree because then the lines get confusing. I just write it like this. Do you see how I just do it across?
This is easier.
Okay, cool. Let's do another one. Let's just practice another one. If you've seen it, cool. If you haven't, cool. It doesn't matter. I need you to show this example in your notes. Focusing. Okay, so we're gonna actually show our work until we're really good at it, and then yes, you can jump right to the answer. Then I'll trust you. But some people need to see the workout. What I want to remind you of is negative 64 can be deceiving. This is actually mathematically negative 1 times 64 times x to the 4th. Is that true? Yes. All right, now once again from here, if you want to do the factor tree thing, factoring it, then you're gonna do it by way number 1. So way number 1 is when you rewrite it completely factored all the way down. So what multiplies to be 64?
8.
8 times. So let's write it. -1 times 8 times 8. And then isn't x to the 4th x times x times x times x? Yes? So we got to keep going. You are not done factoring it till it's linear factors, meaning it does not continue to break down. Does 8 have divisors? Can we divide 8 by something? Yes. There are things that multiply to be 8, so we need to keep going. What is 8 equivalent to?
2, 2, 2.
2 times, okay, so 4 times 2? Or 2 times 2 times 2? Which one do you want to do?
2 times 2 times 2.
All right, let's do this 8. We're going to write right down here a 2 times a 2 times a 2. Isn't that just the 1 8?
Yes.
Then we're going to do this one right down here. We're then going to have another 2 times a 2 times a 2. And then we have x, 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 x. Now, like I said, here we go. How big of groups are we pulling out?
2.
It's a square root. Why are we pulling out groups of 2? Because think about it. Right here, don't we need 2 for it to root cancel out with power? Because then it's like 2 of them. It's a squared, right, everybody? And it's root and power cancel out. That's why we're pulling out groups of 2. So here we go. Let's circle it. We pull out a, I'm going to write my out here. We pull out a 2. We pull out a 2. We pull out a 2. Okay. We pull out x. We pull out x. Now, everyone, now from here, what is the square root of -1?
I.
We pull out I. Yes, everybody? Was there anything left underneath that was not circled?
No.
So the radical is gone. We now multiply that all together. So we have a 2 times a 2 times a 2. What's 2 times 2 times 2? 8. Yes, everybody? Hold on. Let's finish. And then we have x times x, which is x
Squared.
squared, true?
X
And then I doesn't matter. I could put I back here. Want to know the most common way people write it? They usually go 8ix squared. Does order matter? No. No. Multiplication doesn't matter. Could I go like this? I8x squared.
Yes.
This equals this equals this. You're going to see me write it like this because that's just what like has become the norm in math. But it's not mathematically better. It's just the norm. Are we all good? Now, wasn't that a huge pain in the butt? Let's try to think more advancedly so we don't have to do that unless desperate times call for desperate measures. Let's go back and do it a more advanced way. That really is annoying. So watch, we're going to, because we're honors kids, like honestly, not honors kids only can do it that way. We're going to think more advancedly so that our life is easier. Math is supposed to make our life easier. All right, so everybody rewrite it again on the side so you can get really good at this. We have the square root of -1 times 64 times x to the 4th. Okay, so now what we're doing is we're actually just square rooting in sections. Let's just go for it and see if there are any perfect roots in our answer. So we can just do it right here, right now. What's the square root of -1?
I.
What's the square root of 64? What's the square root of x to the 4th?
X squared.
X squared. Now think about y, everybody, okay? So we are, there's 2 ways to think about it. How did they get x squared so quick? Anyone share with me how you got x squared so quick, how you did it? Yes.
Just that it's a square root, so the root is 2, and you just minus 2
Yeah.
off of the exponents.
Okay, so that just happens to be correct even though it's not minus. Yes.
So you have x to the 4th, and
Uh-huh.
you know that it's gonna use 2 x's to get out of there, so you have to use 2 x's twice.
Okay, yes. So he's saying this is x squared times x squared, yes?
Yes.
And then he's saying, so that's x squared squared, yeah?
Yeah.
If there's 2 of them, does not mean something squared. And then it's under the radical. So what is happening? Root and power are canceling out. But that's even more complicating it than it is. Okay, let me urge you to think about this. Do we know that radicals, if we want, can be fractional exponents?
Yes.
So let's think about it like this. If we have an x, what would be the root? 2? Where does that go on my fraction? The bottom. And then where does the power go? Top. So what are we actually doing with the exponents? We're dividing the exponents. Do you guys see? That's just thinking about it as a fraction instead. So then what is 4 divided by 2?
2.
So we have x squared. So that's your answer, right? Let's write it the common way. 8ix squared. Would you guys agree when you think about it more advancedly, it just doesn't take so long? Okay. All right, let's look at another one. Okay, cube root, write it down. Cube root of 8x to the 5th. Now, if you need to do it the long way out, that's fine. No one's judging. If you want to think about it more advancedly, then that's great too. So maybe we should once again do this one the long way and the short way so that we can get good at both. So if we're going to do this the long way, we're going to break it down. What multiplies to be 8?
2, 2, 2.
2 times 2 times 2. Does 2 break down any further? No, so we're good. X to the 5th is 1, 2, 3, 4, 5 x's. True? And now we're pulling out groups of how large?
3.
3. Isn't this a cube root?
Yeah.
So think about this. What undoes a cube root? Power of
3.
3. So we're actually pulling out groups of 3.
So we get 1, 2.
So we pull out a 2. True?
Yes.
We pull out, let's see, 1, 2, 3 x's. We pull out an x. Now, if you look at this, can you pull out groups of 2? No, we only can pull out groups of 3. So that means that's remaining under the cube root. So rewrite your cube root, put what's remaining, x and x, yes? Now, everything was multiplied before. Look at the problem. Is there any addition signs there? No, there's no addition signs, which means it's still no addition signs. It's multiplication. What's 2x? Just 2x, true?
Yeah.
And then we also have the cube root of, what's x times x?
X squared.
X squared. There's our answer.
That's easy.
Oops.
Okay, now let's look. This is going to be for people who don't want to have to do that. If you want to think advancedly, your life is going to be so much easier. In Sec 3 honors, usually when you get to me, I just say, we're cube rooting in sections here. What's the cube root of 8?
3, 2.
2. How many groups of 3 are there in x to the 5th? 1. True, everybody. Isn't there only one group of 3? Aren't we pulling out groups of 3? So I'm pulling out 1x, yes?
Yeah.
But how many did I technically pull out? 3 of them, true? Because you can't pull it out without pulling out 3. So how many remain under the root?
2.
So then left under the cube root was x squared.
That way is way easier.
It just is quicker. It's a different way of thinking though.
Yeah.
Well, let me say that again for people. We cube rooted 8 and it was 2, yes? Now we know we're doing, we're pulling out groups of 1. I'm going to show the visual as I say it. So we're pulling out groups of 3. So we said, in 5 x's, there is 1 group of 3 x's. So we wrote 1x. But we technically pulled out 3 of them. True, it can't leave without the 3 going out. Yes? Which means remaining was x squared. Now if that blows your mind, then draw it out the long way. Okay, try this one right here by yourself. Ready, go.
No sharing answers.
Try it by yourself. Focus, because this is already taking 10 times longer than it should be taking, like at the lesson, because we talk in between each, and we hoot and holler, and we high five, and I like the high fives, but let's kind of like keep focused until the end. Give it a try. Now, if you like to do it the long way, go for it. If you like to do it the short way, go for it. It's all figuring out which math works for you. Math is figure outable. Did you all cross out your name at the door?
I didn't.
Go back and cross it out. Go back and cross it out if you haven't crossed out your name.
You crossed mine too.
Holy cow.
You're losing it, aren't you?
Yeah, I am. This class is already driving me nuts. But I like you, but I'm just like, what am I going to do with these guys? It's hard to get you sophomores to focus. But you're staying focused. I appreciate that. Do you have an answer? Curious, just curious.
I have an answer.
Okay. I just want to hear some answers. It's okay to be wrong.
It's a then odd.
I don't know what to do on the 16.
What?
Like in.
Yeah, you can mix the ways. Yeah, I think that's a really good idea, actually. What's your answer? Just shout it out to
So then
me.
there's 2 different answers.
I got 2y,
No, there's not.
xy.
Say that again.
2y, xy on the outside.
2y, xy?
2y,
I got
2i, xy.
Oh, I. Sorry, I heard something weird. I'm going to write down a few different answers that I hear. 2i, xy. And then what?
And then you have the cube root.
Cube root of?
And then you have 2x squared y.
Interesting. Okay.
I got.
That's just one person's answer. What would you tell me?
I have this.
Okay, then just tell me your answer.
I think that was. I got that exact same.
So you actually got this. And then,
No, I think I'm wrong because there's.
I got something different.
that's why we're writing down all the answers we hear. Okay, what'd you get?
I got 4xy and then the cube root.
Thank you.
X,
It's negative 2x.
X squared. And then Y?
The middle one's right.
I just didn't hear you. What? All right, well, I'm just asking people for people's answers. Then we'll go over it. What's your answer? Give me your answer.
Me?
Him.
Oh.
2xy. 3, whatever.
Cube root. Let's say it right. Cube root.
Negative 2x2y.
I think that's right.
Okay. Did anyone have anything different than any of these answers?
Is it like what? X? Like, you have to have a negative 1 in that. With like a
All right, let's write this out the long way. This is the cube root of negative 1 times 16. True?
Yes.
And then we have x times x times x times x times x 5 times. Did I write that 5 times? Yes. Y, 1, 2, 3, 4. Then from there, you can see if you have perfect cube roots, or if you're a person that needs it broken down all the way, that's fine. You do the cube root of negative 1. Then 16 is 4 times 4. True? X, 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 x. Is that enough x's?
That's more.
And then y, 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 y. And then you're like, oh, but I got to keep going. If you're going to do it this way, you have to factor it all the way down. So now you're going to rewrite this as the cube root of negative 1 times 2 times 2 times 2 times 2. True? And then you have 1, 2, 3, 4, 5. 1, 2, 3, 4. If you have to do it this way, it's fine. Then we're pulling out groups of
3.
Okay, I ignore the negative 1 for right now. For right now, pulling out groups of 3. So I'll pull out a 2. Pull out an X. Pull out a Y. And then I need to remind you, what is the cube root in negative 1? Negative 1, my friends. We pull that out. So now we rewrite it. We say the out stuff is multiplied. This is multiplied, my friends. So isn't that negative 2xy? And then left under the cube root. Let's look with our eyeballs. Left is a 2, an x squared, and a y.
Wait, why does the negative get pulled out?
Once again, what's the cube root of negative 1? Negative 1. Yes.
I got it right.
There's no I when it's an odd root. Now remember why. Negative 1 cubed is negative 1. So the cube root of negative 1 is just negative 1. Okay. All right, let's practice another one. Do you guys feel like you could do better the next time around? Okay, I'll try that. This one. Ready, go. Focus, focus, go, go, go. If you got it wrong, that's a good thing. This is why we're practicing math. Now get it right this time. Try again. It's normal to get math wrong multiple times before you get it right. That is not weird.
Is that a 5 after the y?
Yeah. Give it a try. If you need to do it out the long way, you can. This time I'm going to, once again, we'll do it the long way, but then I'm going to remind people if you want to do it a shorter way, a more advanced way, it goes quicker. We'll go over that too for anyone that wants to see that one more time, the quicker way.
Done, yes. I just do it.
Okay, I'm going to just do it real quick, and then you can compare your answer to mine. Yeah, I know. I'm doing that on purpose so that you can't see my answer till I'm done.
Before you show your
How many of you are still right now, and I'm not, no one's judging, how many of you are still having to do this right now? You're telling me none of you are doing that? Right? Oh, okay. Cool.
I did that.
Trying not to.
Okay, well, we'll practice it without in a minute. All right, so then from here, we're pulling out groups of 2, true?
No, because it's not eliminated.
True.
So we pull out a 2.
8 Y's.
We pull out an X, true? Pull out a y.
What'd you get, Chris?
Pull out another y.
Subtracting 2.
Am I right or wrong?
Correct.
When I'm pulling out a z, I've got to keep my work organized if I'm going to do this. Z again, Z again. True?
Yes.
Pulling out groups of 2. Why are we saying what? So help me know what to answer for you. Say what, and then tell me what I need to help you with.
You should make some season.
Anyone? Okay, so all those are the things I pulled out. I then multiply that. So what would that be? Up here, I'm going to write my answer in red. Multiply all that stuff. That would be 2x
Y
y squared
squared. Z to the 4th.
z times z times z times z. We add our exponents z to the 4th. True? Then you have to go under the square root. Look very carefully. What was left?
6.
3 times 2 is 6. Then y was left. And that's it, right? Admit that's a big pain in the butt. Okay, let me show you. Let's do a mix of the easy and this way. Let me show you. This is going to be your favorite, I bet. So he makes a good point. Up here he was talking and he said, can I do a mix of both? And I thought, you know, that's probably actually your best option. Let's review. Watch. I would do it like this. Are you focusing? Because I can hear chattering and so I can't think. I always, with numbers, if I need to, I break it down into the factor tree. So I'm going to go like this, 24, and I'm going to write it up here so I don't have to write it out so many times. Isn't that 6 times 4?
Yes.
Then I know 6 becomes 3 times 2, and then 4 is 2 times 2. True?
That's exactly what
But then I do not write out a bunch of x's. I do not write out a bunch of y's, and I do not write out a bunch of z's. That's a waste of time. I go like this, x squared, y to the 5th, z to the 8th. And then I say to myself, I'm pulling out groups of 2. True?
Yes.
Okay, so I'm going to pull out a 2. I do this the old-fashioned way. But then from there, I say to myself, okay, now left under my root, I do it like this so I don't get confused, is a 3 and a 2. True?
Yes.
Which is 6. Now watch. Think about this. Groups of 2 means we're dividing by 2. Let's look at our exponents. How many groups of 2 are there in x squared? 1. What's 2 divided by 2?
1.
That's what leaves. X to the 1. Right, everybody?
Correct.
Then how many groups of 2 are there in 5? Okay, so you're saying that then 2, that would be y squared. Now, technically, though, how many y's did you pull out? 4 y's. So how many remain? 1 underneath. True?
Yes.
And then right here, we're doing 8 divided by 2. I'm dividing by 2 because that's the number of groups we're pulling out. What's 8? So then z to the 4th, and done. Do you guys see how combining the ideas is kind of the best option to go quickly and efficiently? Yes.
Can you do it just the advanced way one more time? Just to me, what it makes it really confusing.
Yeah. So I'm going to just jump right into the next one and just do it the advanced way. Okay, so let's look at this one. Watch together so that this can click for you. All right, so I look at this and say to myself, okay, cube root this time. Details matter. Cube root is not the same thing as a square root. I personally, I guess, am with numbers going to do it like this. I'm going to break this into its factors, which means what multiplies to be 32. You can do any factors because we're all going to end up with the same factors in the end. What multiplies to be 32?
8 and 4.
8 times 4, yes? And then I leave it as x squared, y squared, z cubed. Because I don't want to write those out. That's a waste of time in my opinion. So this is the cube root of 8 is 4 times 2. True?
Or just, yeah, true.
4 times 2. And then 4 is
2 times 2.
2 times 2. And then we have this 2. And then 4 is...
2 times 2.
Then I check on, this is a test, a pretend test. I go to my calculator and I go, did I mess up? Is 2 times 2 times 2 times 2 times 2 32? If it is, I'm good. If not, I messed up, right? Okay, now I write it as x squared, y squared, z cubed. And now it's easy. I'm doing groups of
3.
so I pull out a 2. And then I leave some space in case anything else needs to come out. I do a cube root. What's remaining underneath? 2 and a 2. It's not a group of 3, so we multiply anything left underneath back together. Won't that be 4?
Yes.
Okay, I'm good here and here. Now, what size of groups am I pulling?
3.
Now, let's look at x squared. How many groups of 3 are there in x squared?
0.
So x squared has to stay underneath. True?
True.
So you leave x squared underneath. How many groups of 3 are there in y squared? So y squared can't leave. How many groups of 3 are there in z cubed? 1, right? So we pull out z to the 1. Does that make sense? So once again, and the reason, what part's throwing you off? Is it the 1?
It's the extra 2. So 2 times 2 times 2 times 2 times 2. That would be 4 times. Because if 2 times 2 is 4. Then
I bet your brain is going to make more sense of the way I actually do it. This is me pretending like I do it this way. Your brain seems to be doing what I do in real life. Can I show you something? I think you might like this. This is the cube root. Would you agree that 32 is 8 times 4?
yeah.
No, I just cube root. I look for perfect cube roots. Is there a perfect cube root in 8 or 4?
Yes.
Yes. What's the cube root of 8?
2.
What's the cube root of 8?
2.
So I am literally just calculating this in section. I pull out a 2. That's good. So then, is the cube root of 4 calculable? No, so that remains underneath. The cube root of 4. So to me, that's way easier to just cube root in sections. Okay, cool. That's for extra advanced thinkers, because there's room for error there. You have to be careful. All right, let's try. You ready to try a 4th root?
Yes.
Okay, let's do it. Do you want to do it together?
No.
You want to do it by yourself?
Yeah.
Okay, go for it. Go for it. Right here. Go for it. Yeah, right here. Give it a try. This is a 4th root. So what are the group sizes? 4.
Can you do some for me?
Oh my gosh.
So it can't be It's 5, 7, and 3.
Shut up, okay?
It could turn into
It'd actually be 81.
100. What's 4? What's
1.25,
4. No, no decimals. 81. No decimals. Those are bad.
Good. You got 3, 3.
Oh yeah, you're right.
3, 3. Oh, so you just get, it's just 5 in the middle and 3 outside. 81 divided by 9. Because it's 9 times 9 is 81. So take the R is outside.
So, okay, with this one, I don't have my 4th roots memorized, so I have to do it along. But I have square roots memorized, and I have cube roots memorized. So I do it the quick way for all 4 roots. I break down the done.
Yeah.
Then you guys have to check though. Now let's say like for example, let's say you do it the way I was just saying. Let's say you go like this. Like let's say you yeah. 8 times. Let's say you just had this as an example. So is it 8 times 4 32? Okay. So let's say you started with 32, and let's say you started out by saying, I'm going to break it up into 8 times 4. Now here's where you just have to be careful. You're going to do it this way. You have to